Welcome to AI 901 Practice Exam 2. You will work through 45 source-backed questions covering responsible AI, generative AI, language, speech, vision, and information extraction. Use each explanation to strengthen the concept behind the answer, not to memorize answer letters. Here is the rhythm. First, listen to the question and every available choice. Then, lock in your answer during 3 seconds of real silence. After the countdown, review the correct answer, the exam clue, and why the answer works. Matching and ordering questions will reveal the complete mapping or sequence. Question 1 of 45. A municipal government is deploying a public speech-enabled assistant that answers citizen questions about services. The team wants the assistant to work for users with different accents, dialects, speech impairments, and those who prefer text or keyboard input. Which design choice best supports the inclusiveness principle? Choose one. Option A. Support multiple speech patterns, provide real-time captions, allow keyboard or text input, and test with representative diverse users. Option B. Train the model exclusively on standard broadcast English and require voice input only. Option C. Use the highest accuracy single language model and log all interactions for later review. Option D. Limit the assistant to English and disable captions to reduce latency. Lock in your answer before the reveal. The correct answer is A. Support multiple speech patterns, provide real-time captions, allow keyboard or text input, and test with representative diverse users. Exam clue. Inclusiveness requires supporting varied speech, captions, keyboard alternatives, and representative user testing across abilities. Alternative interaction modes and representative testing reveal exclusion that aggregate accuracy can hide. Why this works. Microsoft Responsible AI Inclusiveness Principle emphasizes enabling people with disabilities and diverse backgrounds through alternative interaction methods, captions, and inclusive testing. Question 2 of 45. A bank deploys an AI system that recommends loan products. After 6 months, internal monitoring shows that approval rates for one demographic group are significantly lower than for similarly credit-qualified applicants from other groups. Which action best addresses the fairness principle? Choose one. Option A. Increase the overall approval rate across all groups equally. Option B. Compare approval and error rates across demographic groups and investigate significant disparities. Option C. Remove all demographic attributes from the training data. Option D. Publish a transparency note explaining the model architecture. Lock in your answer before the reveal. The correct answer is B. Compare approval and error rates across demographic groups and investigate significant disparities. Exam clue. Fairness monitoring compares outcome or error rates across groups and investigates root causes of disparities. Compare group-level outcomes rather than relying only on the overall approval rate. Why this works. Microsoft Fairness Guidance requires assessing model performance across sensitive groups and addressing disparities in outcomes, such as selection rates. Question 3 of 45. An industrial company builds an AI assistant that answers technician questions about equipment maintenance procedures using the company's official manuals. Which practice best supports reliability and safety for this assistant? Choose one. Option A. Allow the model to generate creative maintenance tips beyond the manuals when helpful. Option B. Cache all previous answers and reuse them without rechecking the source manuals. Option C. Ground every answer in the official manuals, surface uncertainty or conflicting guidance, and escalate unsafe or high-risk cases to a human expert. Option D. Require every response to include a link to the full manual PDF. Lock in your answer before the reveal. The correct answer is C. Ground every answer in the official manuals, surface uncertainty or conflicting guidance, and escalate unsafe or high-risk cases to a human expert. Exam clue. Reliability and safety for grounded systems requires validating against source documents, surfacing uncertainty, and escalating high-risk cases. High-risk uncertainty should trigger a defined human escalation path. Why this works. Reliability and safety requires AI systems to operate consistently, validate against trusted sources, expose limitations, and include human oversight for high-risk scenarios. Question 4 of 45. A support center uses an AI service to generate summaries of customer calls. The summaries are stored for quality review and must comply with privacy and security requirements. Which two practices best uphold privacy and security principles? Choose 2. Choose 2. Option A. Store only the minimum required summary fields and redact PII before long-term retention. Option B. Include full original call transcripts and customer account numbers in every stored summary. Option C. Restrict summary access to authorized support quality staff using role-based controls. Option D. Embed customer API keys and internal system credentials in the summarization prompts for context. Lock in your answer before the reveal. The correct answers are A. Store only the minimum required summary fields and redact PII before long-term retention, and C. Restrict summary access to authorized support quality staff using role-based controls. Exam clue. Privacy and security require minimizing retained personal data, restricting access, and avoiding secrets or sensitive content in prompts and logs. Why this works. Privacy and security principles require data minimization, access controls, and preventing sensitive information from entering prompts, logs, or storage. Question 5 of 45. A legal aid organization uses an AI assistant to draft case summaries for clients. The summaries are based on court documents and prior filings. Which disclosure approach best meets the transparency principle? Choose one. Option A. Do not mention AI involvement, so clients focus only on the content. Option B. Add a generic footer stating, "This document may contain AI-generated content," without further detail. Option C. Include the full internal prompt used to generate the summary. Option D. Clearly state that AI assisted in drafting, list the primary source documents used, and note that a human reviewed the final summary. Lock in your answer before the reveal. The correct answer is D. Clearly state that AI assisted in drafting, list the primary source documents used, and note that a human reviewed the final summary. Exam clue. Transparency requires telling users when AI assisted, exposing the source basis, and clearly stating limitations of the output. Why this works. Transparency principle requires communicating when and how AI is used, the basis of outputs, and limitations so users can make informed decisions. Question 6 of 45. An organization deploys an autonomous agent that uses tools to update customer records. To satisfy accountability, must the organization assign named human owners who review and approve consequential agent-initiated changes before they are committed? Choose one. Option A, yes. Option B, no. Lock in your answer before the reveal. The correct answer is A, yes. Exam clue. Accountability requires named owners, auditable actions, and human approval for consequential changes, rather than relying solely on service principles. Why this works. Accountability in responsible AI demands clear ownership and auditable human-in-the-loop controls for agents performing actions with business impact. The service principle alone does not provide named accountability or approval workflow. Question 7 of 45. A developer prompts a generative model with a customer support scenario. Which statement best describes how the model produces its reply? Choose one. Option A. It predicts the next token one at a time based on statistical patterns learned during training and the tokens already in context. Option B. It retrieves a pre-written answer that exactly matches the prompt from a database. Option C. It executes deterministic business rules coded into the model weights. Option D. It searches the internet in real time for the most current factual answer. Lock in your answer before the reveal. The correct answer is A. It predicts the next token one at a time based on statistical patterns learned during training and the tokens already in context. Exam clue. Next token prediction uses learned patterns plus current context window. Generation is probabilistic, not retrieval or rule execution. It does not retrieve a guaranteed factual sentence from storage. Why this works? Generative models work by autoregressive token prediction. Each new token is sampled from the probability distribution conditioned on prior tokens and the prompt context. Output is inherently probabilistic rather than retrieval or rule-based. Question 8 of 45. A user pastes a 20-page internal policy document into the context window of a chat model and asks it to answer a factual question about vacation policy. The model returns a confident but incorrect statement. Which limitation explains this behavior? Choose one. Option A. The model has a fixed context length that prevents it from reading the entire document. Option B. Context supplies guidance for generation, but does not force the model to ground every claim in the supplied text or guarantee factual accuracy. Option C. The model deliberately fabricates answers when it detects internal policy content. Option D. Context windows only support keyword matching, not semantic understanding. Lock in your answer before the reveal. The correct answer is B. Context supplies guidance for generation, but does not force the model to ground every claim in the supplied text or guarantee factual accuracy. Exam clue. Context window supplies guidance, but never guarantees every generated claim will be factually supported by the provided material. Why this works? Even with relevant context provided, generative models can produce unsupported or hallucinated statements because they optimize for fluent continuation rather than strict fidelity to source. Grounding techniques or RAG are required to mitigate this. Question 9 of 45. A team must build a low-latency internal tool that classifies short text tickets into categories and extracts key entities. The tool will never receive images or generate images. Which model selection best satisfies the requirements? Choose one. Option A. A large multimodal model that accepts both text and images. Option B. An image generation model fine-tuned on ticket screenshots. Option C. A small text-only model optimized for classification and entity extraction. Option D. A speech-to-text model because tickets may arrive as voice notes. Lock in your answer before the reveal. The correct answer is C. A small text-only model optimized for classification and entity extraction. Exam clue. Select modality-matched capability first. Text-only classification task needs small text model, not multimodal or image or speech variants. Extra modalities add cost without helping a text-only task. Why this works? Model selection must align exactly with required input or output modalities and task capabilities. A small text-only model delivers lower cost and latency for pure text classification or extraction without extraneous multimodal overhead. Question 10 of 45. Match each temperature setting concept with its correct effect on model output behavior. Match the pairs. Item A, temperature equals 0.0. Item B, temperature equals 1.0. Item C, higher temperature values. Item D, lower temperature values. Target 1, Default creative sampling that balances coherence and diversity. Target 2 increases output randomness and creativity, but does not improve factual grounding. Target 3 decreases output randomness, favoring more focused and repetitive responses. Target 4 produces the most deterministic, repeatable output, still relies entirely on training data and context for factual content. Match each item to the best target before the reveal. The correct matches are: Item A matches produces the most deterministic, repeatable output, still relies entirely on training data and context for factual content. Item B matches default creative sampling that balances coherence and diversity. Item C matches increases output randomness and creativity, but does not improve factual grounding. Item D matches decreases output randomness, favoring more focused and repetitive responses. Exam clue. Temperature controls sampling randomness. Lower values reduce variability, while higher values increase creativity. No temperature setting adds knowledge or grounding. Why this works. Temperature is a sampling parameter that controls randomness in token selection. Lower values produce more deterministic output. However, no temperature setting adds knowledge, performs grounding, or prevents unsupported claims. Those require retrieval or system instructions. Question 11 of 45. A developer cannot invoke a deployed Microsoft Foundry model from code, even though the API key is confirmed valid. Which two configuration elements must be verified to establish a callable endpoint? Choose one. Option A, the exact deployment name assigned to the model. Option B, the complete endpoint URL, resource endpoint plus or OpenAI or deployments or. Option C, the temperature parameter set to 0.0 in the request body. Option D, the total parameter count of the underlying foundation model. Lock in your answer before the reveal. The correct answers are A, the exact deployment name assigned to the model, and B, the complete endpoint URL, resource endpoint plus or OpenAI or deployments or. Exam clue. Deployment name routes the request, while endpoint URL plus credential complete the connection to the deployed model. Generation settings matter only after the request reaches the intended deployment. Why this works. A callable deployment requires both the deployment name, used in the model parameter of requests, and the endpoint URL. Authentication, key or Entra ID token, completes the configuration. Sources confirm deployments expose models via named endpoints with standard auth. Question 12 of 45. A procurement workflow must research vendors, call external pricing APIs, compare options, and execute a purchase across multiple dependent steps. Which workload pattern is the best fit? Choose one. Option A, single-turn generative model that produces one response per prompt. Option B, keyword extraction pipeline for document indexing only. Option C, speech synthesis model for voice notifications. Option D, Agentic AI solution that can use tools and maintain multi-step reasoning. Lock in your answer before the reveal. The correct answer is D, Agentic AI solution that can use tools and maintain multi-step reasoning. Exam clue. Agentic pattern enables tool calling and multi-step orchestration, while single-turn generation stops after one response. Tool use and multi-step action are the decisive agentic signals. Why this works. Agentic designs are appropriate when the scenario requires tool use, planning, and sequential actions over multiple turns. Plain generative models are suited to single response tasks. Question 13 of 45. Which two statements accurately distinguish key phrase extraction from named entity recognition in Azure AI Text Analytics? Choose one. Option A. Key phrase extraction returns the most salient concepts and topics mentioned in the text. Option B. Named entity recognition identifies and categorizes specific named items, such as people, organizations, and locations. Option C. Key phrase extraction always returns a sentiment polarity score for each phrase. Option D. Named entity recognition primarily compresses long documents into shorter summaries. Lock in your answer before the reveal. The correct answers are A. Key phrase extraction returns the most salient concepts and topics mentioned in the text, and B. Named entity recognition identifies and categorizes specific named items, such as people, organizations, and locations. Exam clue. Key phrases highlight salient topics. Named entities label specific people, organizations, and places. One returns salient concepts. The other returns categorized named items. Why this works? Key phrase extraction surfaces important concepts without requiring them to be named entities. Named entity recognition specifically detects and labels proper nouns and known entity types. Question 14 of 45. A compliance system must pull specific structured values, policy ID, effective date, and coverage amount, from lengthy legal documents. Which workload directly satisfies the requirement? Choose one. Option A. Information extraction that returns requested fields and entities. Option B. Abstractive or extractive summarization of the full document. Option C. Key phrase extraction limited to the top 5 concepts. Option D. Sentiment analysis, producing a single positive or negative score. Lock in your answer before the reveal. The correct answer is A. Information extraction that returns requested fields and entities. Exam clue. Summarization compresses overall meaning. Information extraction returns specific requested fields and entities. Decide whether the output needs prose compression or consistent fields. Why this works. Information extraction is designed to pull targeted fields and entities into structured output. Summarization compresses overall meaning without enforcing a schema. Question 15 of 45. Does the Azure AI Speech Service support both real-time speech-to-text for live captions and text-to-speech synthesis for spoken audio playback within the same service? Choose one. Option A. Yes, speech-to-text recognition produces captions from audio, while text-to-speech synthesis generates spoken output from text. Option B. No. Live captions and spoken playback require two completely separate Azure services. Lock in your answer before the reveal. The correct answer is A. Yes, speech-to-text recognition produces captions from audio, while text-to-speech synthesis generates spoken output from text. Exam clue. Recognition converts speech to text for captions. Synthesis converts text to audio for playback, both in Azure AI Speech. Why this works? Azure AI Speech provides unified speech recognition for converting audio to text, enabling live captions, and speech synthesis for converting text back to natural audio, enabling spoken playback. Question 16 of 45. A field service mobile app processes equipment photos. Match each requested output to the correct vision workload capability. Choose one. Item A. Assign a single equipment type label to each photo. Item B. Return bounding boxes around visible damage or wear. Item C. Extract printed serial numbers and model text from labels. Item D. Produce a new synthetic illustration of a repaired component. Target 1, object detection. Target 2, OCR. Target 3, image generation. Target 4, classification. Match each item to the best target before the reveal. The correct matches are: item A matches classification, item B matches object detection, item C matches OCR, item D matches image generation. Exam clue: match requested output type, label, location box, text string, or new image to the workload that produces it. Why this works: classification labels the whole image, object detection returns locations, OCR reads text, and image generation creates new content. These map directly to Azure AI Vision capabilities and generative image models in Foundry. Question 17 of 45. A compliance team needs to pull structured fields such as dates, parties, and key terms from customer contracts stored as scanned PDFs, recorded calls, and short product videos. Which 4 input modalities support direct information extraction workloads? Choose 4. Option A, text documents and PDFs. Option B, images and scanned documents. Option C, audio recordings and calls. Option D, video clips with visual and spoken content. Option E, live sensor telemetry streams. Lock in your answer before the reveal. The correct answers are A, text documents and PDFs, and B, images and scanned documents, and C, audio recordings and calls, and D, video clips with visual and spoken content. Exam clue: extraction converts existing content in supported media types into structured fields. Live telemetry is outside the typical content extraction pattern. Why this works: information extraction applies across text, image, including OCR on scans, audio, speech-to-text, then extraction, and video, visual plus audio channels. Azure AI Document Intelligence, Speech, and Vision support these modalities for structured output. Question 18 of 45. An archive team processes a library of historical meeting recordings. Which operation produces genuinely new content rather than structured information pulled from existing media? Choose 1. Option A, extract attendee names, action items, and dates into a CSV. Option B, create an original artistic poster image inspired by the meeting theme. Option C, generate a concise summary paragraph of the discussion. Option D, identify and list all mentioned product SKUs from the transcript. Lock in your answer before the reveal. The correct answer is B, create an original artistic poster image inspired by the meeting theme. Exam clue: new creative artifact, poster, is generation. Pulling names, SKUs, or summaries from recordings is extraction. Ask whether the system creates new content or analyzes existing content. Why this works: generation creates novel content, new image, story, or design. Extraction, summarization, and entity listing derive structured data from what already exists in the source media. Question 19 of 45. A global support center receives a 90-second customer video in Spanish that contains spoken complaint details, on-screen product photos, and background factory noise. The team needs transcription, translation to English, visual defect identification, and structured extraction of serial numbers and timestamps. Which combination of workloads should be orchestrated? Choose 1. Option A, image classification only plus a single generative summary. Option B, video generation to recreate the scene in English. Option C, speech recognition, text translation, vision analysis, and information extraction. Option D, text-only key phrase extraction after manual transcription. Lock in your answer before the reveal. The correct answer is C, speech recognition, text translation, vision analysis, and information extraction. Exam clue: decompose spoken, speech, visual, vision, and text extraction needs across the video's audio and image channels. Route each modality through the capability that transforms that input correctly. Why this works: multilingual media requires speech to text with language ID, translation, computer vision for visuals, and extraction for entities or numbers. Azure AI Speech, Translator, Vision, and Document Intelligence, or Content Understanding, cover the pipeline. Question 20 of 45. A customer support chatbot must never give medical, legal, or financial advice. The system prompt states this policy explicitly and instructs the model to redirect such queries. A user then asks for help interpreting recent lab results. Which prompt element governs the response? Choose one. Option A, the current user message alone. Option B, model temperature setting. Option C, the deployment name of the underlying model. Option D, the durable system instructions defining boundaries and redirection. Lock in your answer before the reveal. The correct answer is D, the durable system instructions defining boundaries and redirection. Exam clue: system instructions define durable boundaries and redirection. User prompt supplies the current request only. Current user request should not redefine the assistant's persistent safety boundaries. Why this works: system prompts establish persistent instructions, safety policies, and behavior that take precedence over individual user requests. User prompts provide context for the current turn only. Question 21 of 45. A developer is building a customer support assistant that must answer only from a curated internal knowledge base. The assistant occasionally fabricates answers when the query falls outside the provided documents. Which two prompt techniques best enforce a grounded answer contract? Choose two. Option A, instruct the model to always provide the most helpful answer, regardless of source. Option B, include the full curated knowledge base in the system message and reference it in every user prompt. Option C, add a temperature equals 0 parameter and increase max tokens. Option D, require the model to cite the exact document and paragraph or respond with, "I do not have enough information." Lock in your answer before the reveal. The correct answers are B, include the full curated knowledge base in the system message and reference it in every user prompt. And D, require the model to cite the exact document and paragraph or respond with, "I do not have enough information." Exam clue: grounding contracts supply trusted context and require the model to cite sources or explicitly abstain when evidence is missing. Why this works: Microsoft Foundry guidance for grounded agents emphasizes providing trusted context and instructing the model to cite or abstain rather than guess. Question 22 of 45. A team has selected a model in the Microsoft Foundry portal, but the deploy button remains disabled and no endpoint appears after 30 minutes. Does the correct next diagnostic step include verifying that a compatible deployment SKU and region have been chosen before testing prompts? Answer yes or no. Option A, yes, confirm deployment SKU and region compatibility first. Option B, no, skip deployment and test prompts directly in the playground. Lock in your answer before the reveal. The correct answer is A, yes, confirm deployment SKU and region compatibility first. Exam clue: portal deployment requires selecting a supported model, creating a compatible deployment in the chosen region, then testing prompts. Why this works: Microsoft Foundry portal flow requires model selection followed by explicit deployment creation with compatible configuration before any prompt interaction. Question 23 of 45. A developer needs a minimal Python client to send messages to a deployed Foundry model and receive streaming responses. Which initialization correctly creates a lightweight chat client using the current Foundry SDK pattern? Choose one. Option A. Project equals AI project client equals project endpoint, credential equals credential. Client equals project.get OpenAI client. Option B. Client equals OpenAI.API-key.canary.guide.execute Azure OpenAI key. Option C. Client equals AI project client pattern. Module equals GPT-5 mini. Option D. Client equals Azure OpenAI. Azure endpoint equals endpoint. API key.query API version Prumpet 2024-10-01 preview. Lock in your answer before the reveal. The correct answer is A. Project equals AI project client. Dushwick equals project endpoint. Credential equals credential. Client equals project.get OpenAI client. Exam clue. Use AI project client with project endpoint and credential, then call project.get OpenAI client for the chat interface. Model target and authentication still come from the configured Foundry project. Why this works. Use AI project client with the Foundry project endpoint and credential, then obtain the project scoped OpenAI compatible client for chat requests. Question 25 of 45. An operations team wants a single Foundry agent that can look up internal policy documents and draft replies, but must never perform write operations without explicit confirmation. Match each portal action to the correct agent lifecycle stage. Match the items. Item authoring. Define agent instructions and safety rules. Item tool configuration. Attach Azure AI search tool with read-only index. Item testing and validation. Run test queries in the portal playground and review tool calls. Item governance and safety. Review permission logs and require human approval for any write action. Target 1. Tool configuration. Target 2. Testing and validation. Target 3. Governance and safety. Target 4. Authoring. Match each item to the best target before the reveal. The correct matches are item, define agent instructions and safety rules matches authoring. Item, attach Azure AI search tool with read-only index matches tool configuration. Item, run test queries in the portal playground and review tool calls matches testing and validation. Item, review permission logs and require human approval for any write action matches governance and safety. Exam clue, single agent lifecycle, author instructions, add approved tools, test behavior and permissions, enforce governance boundaries in the portal. Each stage has a distinct authoring, testing, or control responsibility. Why this works. Foundry single agent creation in the portal follows a clear sequence of authoring instructions, configuring approved tools, testing behavior, and applying governance controls. Question 26 of 45. A developer creates a prompt agent in the Foundry portal to help with internal ticket routing. The agent is given a tool that can both read ticket data and send emails to customers. The team is concerned about unintended actions. Does granting the agent the combined read and send tool without additional controls align with safe agent tool practices? Choose yes or no. Option A. Yes. The agent should have full tool access to complete tasks without interruption. Option B. No. grant only the minimum required tool operations, and require confirmation for any action that affects external systems. Lock in your answer before the reveal. The correct answer is B, no. Grant only the minimum required tool operations and require confirmation for any action that affects external systems. Exam clue. Safe agent tool use requires least privileged tool scopes plus explicit confirmation steps for any action that changes external state. Why this works. Foundry Agent Service Tool best practices emphasize configuring minimal tool permissions and human approval workflows for actions that modify state or communicate externally. Question 27 of 45. A team has tested a single agent solution in the Foundry portal that includes custom instructions and approved tools. They now want to call it from a lightweight application. Which client approach correctly targets the tested agent configuration rather than a raw model deployment? Choose one. Option A. Use the standard chat completions endpoint with the deployed model name and supply the instructions in every request. Option B. Connect to the published agent application endpoint or use the agent framework client configured for that agent. Option C. Call the model playground URL directly from the application code. Option D. Use the same Foundry chat client as a plain model chat and ignore the portal agent. Lock in your answer before the reveal. The correct answer is B. Connect to the published agent application endpoint or use the agent framework client configured for that agent. Exam clue. When instructions and tools live in the agent definition, the application must connect to the agent endpoint or published agent application, not a direct model chat client. Why this works. Foundry documentation distinguishes agent clients, which inherit portal configuration, from direct model chat clients. The agent endpoint or agent framework is required to preserve tested instructions and tools. Question 28 of 45. A developer is building a lightweight client that starts conversations with a tested Foundry agent and handles tool results returned by the agent. Place the steps in the correct execution order for a typical agent conversation that may invoke tools. Order the steps from first to last. Step A. Execute the selected tool locally or via MCP and return the structured result to the agent. Step B. Create a new conversation, thread, or reuse an existing one with the agent. Step C. Receive and display the agent's final response after tool results are incorporated. Step D. Send the user message. The agent evaluates instructions and may request a tool call. Put the steps in the best order before the reveal. The correct order is 1. B. Create a new conversation thread, or reuse an existing one with the agent. Then 2. D. Send the user message. The agent evaluates instructions and may request a tool call. Then 3. A. Execute the selected tool locally or via MCP, and return the structured result to the agent. Then 4. C. Receive and display the agent's final response after tool results are incorporated. Exam clue. Agent flow begins with conversation creation or message send. Lets the agent decide on approved tools. Then the client supplies tool results back for final response generation. Why this works. Foundry agent conversation lifecycle follows thread creation, message submission, agent decides tool use, tool execution plus result return, then final agent response generation. Question 29 of 45. A team has built a grounded assistant in Foundry that answers questions using approved internal documents. They want to measure quality before wider rollout. Which two practices best support reliable evaluation of the grounded assistant? Choose two. Option A. Run the assistant only on the exact prompts used during development. Option B, test with a diverse set of representative prompts and verify that answers cite the expected source passages. Option C, measure only token usage and latency without checking factual correctness. Option D, include known failure case prompts and iterate on instructions or retrieval after reviewing results. Lock in your answer before the reveal. The correct answers are B, test with a diverse set of representative prompts and verify that answers cite the expected source passages. And D, include known failure case prompts and iterate on instructions or retrieval after reviewing results. Exam clue. Effective evaluation uses representative prompts, checks that answers cite expected evidence, tests known failure cases, and iterates on results. Why this works. Foundry evaluation guidance stresses representative test sets, evidence verification, failure case coverage, and iterative refinement of prompts and grounding. Question 30 of 45. After deploying an agent and configuring a lightweight client, calls from the application return authentication or authorization errors while the portal playground works correctly. Which diagnosis most directly explains why the client fails but the portal succeeds? Choose one. Option A, the model deployment itself has become unavailable in the region. Option B, the agent instructions contain a syntax error that only manifests at runtime. Option C, the client application is using an identity or token that lacks the required Foundry project permissions or is pointed at the wrong endpoint. Option D, the client SDK version is outdated and incompatible with the deployed agent runtime. Lock in your answer before the reveal. The correct answer is C. The client application is using an identity or token that lacks the required Foundry project permissions, or is pointed at the wrong endpoint. Exam clue. Portal success with client failure typically indicates mismatched credentials, insufficient RBAC permissions on the client identity, or incorrect endpoint or project configuration. Why this works. Foundry authentication and authorization docs emphasize that portal access uses the signed-in user context, while client applications require explicit identity configuration, correct scopes, and endpoint alignment. Question 31 of 45. A developer is building a lightweight Python app that processes incoming customer support tickets. The app must extract named entities, such as product names and locations, plus key phrases that summarize the issue. Which two actions correctly implement the entity and key phrase analysis pipeline using Foundry text capabilities? Choose exactly two. Option A, invocation the text analytics client, call recognized entities and extract key phrases on the ticket text, then read the results arrays. Option B, use the speech SDK to transcribe any attached audio before running text analysis on the transcript. Option C, send the full ticket text directly to a generative model and ask it to list entities in free text. Option D, configure the client with the correct Foundry endpoint and key, then iterate over the entities and key phrases returned in the response objects. Lock in your answer before the reveal. The correct answers are A, initialization the text analytics client, call recognize entities and extract key phrases on the ticket text, then read the results arrays. And D, configure the client with the correct Foundry endpoint and key, then iterate over the entities and key phrases returned in the response objects. Exam clue. Route text through the language service client for named entity recognition and key phrase extraction, then parse the structured JSON results. Why this works. Azure AI Language, via Foundry, provides dedicated recognize entities and extract key phrases operations that return structured results suitable for downstream processing in a lightweight app. Question 32 of 45. A support team wants to analyze a nightly batch of 500 customer feedback messages. They need sentiment scores, detected language, named entities, and key phrases for each message to populate a dashboard. Which single capability selection and result mapping best supports the required batch feedback analysis outputs? Choose one. Option A. Use only the speech service batch transcription endpoint and map audio duration to sentiment. Option B. Call a single generative chat completion endpoint and instruct the model to return JSON with all 4 fields. Option C. Deploy a custom vision model to classify feedback screenshots and ignore the text content. Option D. Use the text analytics client batch methods for sentiment analysis, language detection, entity recognition, and key phrase extraction. Map each response field to the dashboard columns. Lock in your answer before the reveal. The correct answer is D. Use the text analytics client batch methods for sentiment analysis, language detection, entity recognition, and key phrase extraction. Map each response field to the dashboard columns. Exam clue. Select the Language Service Batch API that returns sentiment, language, entities, and key phrases in one structured response per document. Why this works. The Azure AI Language Service in Foundry tools supports batch calls that return multiple analysis results, sentiment, language, entities, key phrases, in structured form for easy dashboard ingestion. Question 33 of 45. A developer records a spoken question on a mobile device and wants the app to send the audio to a deployed multimodal model in Foundry, receive a text answer, and display it. Does capturing audio, converting it to text via speech to text, then sending the transcribed text plus any image context to the multimodal model deployment satisfy the spoken prompts objective? Choose yes or no. Option A. Yes, convert spoken input to text with the speech service, then invoke the multimodal model deployment with the transcribed prompt. Option B. No. Multimodal models cannot accept any form of spoken or audio input, even after transcription. Lock in your answer before the reveal. The correct answer is A. Yes. Convert spoken input to text with the speech service, then invoke the multimodal model deployment with the transcribed prompt. Exam clue. Spoken prompts reach a multimodal model after speech-to-text conversion. The multimodal deployment then processes the resulting text and optional images. Why this works. Spoken prompts are handled by first using Azure Speech to obtain text, then routing that text to the multimodal model endpoint as a standard prompt. Question 34 of 45. A developer must implement real-time speech recognition in a lightweight Foundry app that captures microphone audio and returns recognized text. Place the steps in the correct order to build the speech recognition flow using Azure Speech in Foundry tools. Order the steps from first to last. Step A. Subscribe to the recognized event and extract the text from each speech recognition dysfunctional result. Step B. Create a speech config from the Foundry speech endpoint and subscription key, then instantiate a speech recognition. Step C. Call stop continuous recognition async and dispose the recognizer when the session ends. Step D. Start continuous recognition async on the recognizer attached to the default microphone input. Put the steps in the best order before the reveal. The correct order is 1B. Create a speech config from the Foundry speech endpoint and subscription key, then instantiate a speech recognition. Then 2D. Start continuous recognition async on the recognizer attached to the default microphone input. Then 3A. Subscribe to the recognized event and extract the text from each speech recognition async result. Then 4C. Call stop continuous recognition async and dispose the recognizer when the session ends. Exam clue. Create speech resource and client. Start continuous recognition on audio input. Handle recognized text events, then stop and clean up the session. Why this works. Azure Speech Recognition Flow requires first configuring and creating the recognizer client, starting continuous recognition to receive events, processing recognized text from those events, and stopping the recognizer on completion. Question 35 of 45. An application needs to convert dynamic text responses from a chat model into natural-sounding audio that can be played back to the user with a selected neural voice. Which single approach correctly implements the speech synthesis, text-to-speech, app flow using Azure Speech in Foundry tools? Choose one. Option A. Create a speech config with the Foundry speech endpoint, instantiate speech synthesizer, set a neural voice, call speak text async on the text, and play the audio result. Option B. Use the language service batch API to generate audio descriptions and ignore voice selection. Option C. Send the text to a multimodal vision model and request an image of a waveform instead of audio. Option D. Deploy a custom speech-to-text model and reverse its output direction for synthesis. Lock in your answer before the reveal. The correct answer is A. Create a speech config with the Foundry speech endpoint, instantiate speech synthesizer, set a neural voice, call speak text async on the text, and play the audio result. Exam clue. Configure speech synthesizer with a neural voice, call speak text async on the generated text, and play the returned audio stream or file. Why this works. Azure Speech Synthesis in Foundry Tools uses the speech synthesizer client with a chosen neural voice to convert text to playable audio in a single supported flow. Question 36 of 45. A field technician uses a lightweight mobile app to photograph equipment and ask natural language questions about visible damage or part numbers in the image. Which client configuration correctly implements the image plus text inspection flow against a deployed multimodal model? Choose one. Option A. Upload the image to a separate vision resource, then send only the text question to a text-only chat deployment. Option B. Create a multimodal chat client pointing to the deployed model, include the image attachment plus the technician's question in the user message, and process the response. Option C. Convert the image to base64 text description first, then send only the generated description to the model. Option D. Use the speech service to describe the photo aloud, then transcribe and send only the audio transcript. Lock in your answer before the reveal. The correct answer is B. Create a multimodal chat client pointing to the deployed model. Include the image attachment plus the technician's question in the user message and process the response. Exam clue. Instance multimodal chat client. Attach the captured image and text prompt in the same message, then stream or await the model response. Why this works. Deployed multimodal models in Azure AI Foundry accept images and text together in chat messages, enabling direct visual question answering in lightweight clients. Question 37 of 45. An inspection app sends a low-resolution or partially obscured photo of a safety label together with the question, what does the warning label say and what hazard level is indicated? Should the prompt to the multimodal model explicitly instruct it to state uncertainty or reply, I cannot determine, when the image quality prevents reliable reading? Choose yes or no. Option A, yes. Include explicit instructions for the model to report low confidence or state it cannot read the label when image clarity is insufficient. Option B, no. The model should always attempt a best guess answer, even on blurry images, to maximize automation. Lock in your answer before the reveal. The correct answer is A. Yes. Include explicit instructions for the model to report low confidence or state it cannot read the label when image clarity is insufficient. Exam clue. Reliability requires the model to express uncertainty on ambiguous visual input, rather than hallucinate label text or hazard details. Why this works. Prompt engineering for vision models must include uncertainty handling when image quality is poor to maintain trustworthy outputs. Question 38 of 45. A training department needs original illustrations of safety procedures that do not exist in stock photography. They want to generate them from detailed text descriptions inside a lightweight internal tool. Which action correctly fulfills the new visual outputs requirement using Azure image generation capabilities? Choose one. Option A. Use the multimodal analysis model to edit an existing photo by describing changes in text. Option B. Submit the description to a text-only chat model and ask it to output SVG code for the illustration. Option C. Invoke the deployed image generation model with the detailed procedure description as the prompt and save the returned image URL or bytes. Option D. Upload a reference photo to the Vision service and request a style transfer output. Lock in your answer before the reveal. The correct answer is C. Invoke the deployed image generation model with a detailed procedure description as the prompt, and save the returned image URL or bytes. Exam clue. Call the image generation model deployment with a precise prompt describing the desired training illustration, and retrieve the generated image asset. Why this works. Azure image generation models in Foundry are the designated service for creating new visual assets from natural language prompts. Question 39 of 45. A developer is writing a lightweight client that submits a product photo to a deployed multimodal vision model and consumes the structured JSON response, containing detected objects, colors, and a short description. Place the steps in the correct order to implement the vision client request and response flow. Order the steps from first to last. Step A. Construct the user message containing the image reference and any accompanying text prompt. Step B. Iterate over the returned objects, description, and metadata to update the application UI or database. Step C. Initialize the multimodal chat client with the correct Foundry endpoint, deployment name, and credentials. Step D. Call the chat completions or messages method on the client and await the model response containing structured vision output. Put the steps in the best order before the reveal. The correct order is 1. C. Injectable the multimodal chat client with the correct Foundry endpoint, deployment name, and credentials. Then 2. A. Construct the user message containing the image reference and any accompanying text prompt. Then 3. D. Call the chat completions or messages method on the client and await the model response containing structured vision output. Then 4. B. Iterate over the returned objects, description, and metadata to update the application UI or database. Exam clue. Configure the multimodal client and endpoint first, attach the image to the prompt, send the request, then parse the structured response object for downstream use. Why this works. Lightweight vision clients follow the sequence of client setup, prompt assembly with image, request execution, and structured result consumption. Question 40 of 45. An app must both 1. Extract every printed character exactly from a scanned compliance form, and 2. Answer semantic questions about the visual layout and any handwritten annotations on the same image. Which two routing decisions correctly separate the exact text capture from the visual reasoning task? Choose exactly 2. Option A. Route both tasks to the same multimodal model and ask it to return both raw text and semantic answers in one call. Option B. Send the image to the Azure Vision OCR capability to obtain the exact printed text string or bounding boxes. Option C. Send the same image plus a reasoning prompt to the deployed multimodal vision model to interpret layout and handwritten notes. Option D. Use only the image generation model to recreate the form and then compare pixel differences. Lock in your answer before the reveal. The correct answers are B. Send the image to the Azure Vision OCR capability to obtain the exact printed text string or bounding boxes. And C. Send the same image plus a reasoning prompt to the deployed multimodal vision model to interpret layout and handwritten notes. Exam clue. Send the form image to the dedicated OCR capability for precise text extraction and to the multimodal vision model for layout understanding and annotation reasoning. Why this works. Azure Vision provides distinct OCR endpoints for exact text capture and multimodal models for semantic visual reasoning. Routing each task to the appropriate capability meets both requirements. Question 41 of 45. A company uses Azure Content Understanding to process new employee onboarding packets. Match each required step in the extraction workflow to the correct action performed by the analyzer. Choose one. Item A. Define a custom schema listing required fields such as employee ID, start date, and emergency contact. Item B. Upload the completed PDF and image files to the Content Understanding Analyzer endpoint. Item C. Review extracted field values and confidence scores before committing data to the HR system. Item D. Invoke the analyzer with the defined schema to produce structured JSON output. Target 1. Upload content. Target 2. Invoke analyzer. Target 3. Review output. Target 4. Define schema. Match each item to the best target before the reveal. The correct matches are: Item A matches define schema. Item B matches upload content. Item D matches invoke analyzer. Item C matches review output. Exam clue. Schema first, upload content, invoke analyzer, then review structured JSON before HR commit. Keep human validation after structured output and before committing business records. Why this works. A complete schema-based document extraction workflow requires defining the target fields first, supplying content, invoking the analyzer to generate structured output, and finally reviewing results for accuracy before system ingestion. Sources confirm. Content understanding analyzers use custom schemas for documents and forms to produce validated JSON. Question 42 of 45. A warehouse mobile app photographs product labels containing printed SKU, lot number, and expiration date. Which Azure service capability directly extracts these specific fields into structured output? Choose one. Option A. Pre-built OCR engine that returns only raw text blocks without field mapping. Option B. Image classification model that assigns a single category label to the entire photo. Option C. Object detection model that draws bounding boxes around text regions only. Option D. Azure Content Understanding Image Analyzer configured with a custom schema for label fields. Lock in your answer before the reveal. The correct answer is D. Azure Content Understanding Image Analyzer configured with a custom schema for label fields. Exam clue. Schema-driven image analyzer turns photograph label text into typed SKU, lot, and expiration fields. Raw OCR alone does not map values into the required business fields. Why this works. Content Understanding supports custom analyzers for images that combine OCR with schema-driven field extraction, producing structured JSON with named fields and confidence scores for photograph labels. This matches the official bullet for images with Content Understanding. Question 43 of 45. A safety team records equipment inspection videos. Can Azure Content Understanding extract specific events, named entities such as equipment IDs, and time-stamped evidence directly from the video recording without first producing a full transcript. Choose one. Option A, yes. Option B, no. Lock in your answer before the reveal. The correct answer is A, yes. Exam clue. Video schema fields for events and timestamps are populated directly by the multimodal analyzer. A separate full transcript is not always required before targeted extraction. Why this works. Azure Content Understanding video analyzers accept a field schema and use generative models to populate structured fields, events, entities, timestamps directly from multimodal input, enabling targeted extraction without requiring a separate full transcription step first. This aligns with the official D2.4 audio or video bullet. Question 44 of 45. A compliance officer needs to extract named speakers, detected sentiment per segment, and specific compliance violation keywords from recorded customer service calls. Which approach satisfies the requirement most precisely? Choose one. Option A. Use an Azure Content Understanding audio analyzer with a custom schema defining speaker, sentiment, and keyword fields. Option B. Run Azure Speech Transcription to obtain a full text transcript, then apply separate text analysis tools. Option C. Apply only keyword extraction on raw audio waveform data without any transcription step. Option D. Generate a summary paragraph with a generative model and manually scan the summary for violations. Lock in your answer before the reveal. The correct answer is A. Use an Azure Content Understanding audio analyzer with a custom schema defining speaker, sentiment, and keyword fields. Exam clue. Custom audio schema with speaker, sentiment, and keyword fields produces structured compliance evidence directly. Choose schema extraction when the output must be structured rather than transcript only. Why this works. When structured semantic fields beyond raw text are required, speakers, per segment sentiment, targeted keywords, content understanding audio analyzers with custom schemas deliver the exact structured output in a single multimodal pass, distinguishing it from plain transcription workflows. Question 45 of 45. A developer builds a lightweight permit processing client that must extract fields from uploaded building permit PDFs and allow a human reviewer to approve results before saving. Which three actions must the client perform to complete the workflow end-to-end? Choose three. Option A. Upload the PDF to a content understanding analyzer configured with the permit schema. Option B. Invoke the analyzer and retrieve the structured JSON result containing extracted fields and confidence scores. Option C. Store the raw PDF bytes in a relational database without further processing. Option D. Present the extracted fields to a reviewer for approval and persist only the approved values. Lock in your answer before the reveal. The correct answers are A. Upload the PDF to a content understanding analyzer configured with the permit schema, and B. Invoke the analyzer and retrieve the structured JSON result containing extracted fields and confidence scores. And D. Present the extracted fields to a reviewer for approval and persist only the approved values. Exam clue. Upload to schema analyzer, retrieve structured result, human review, then save approved fields only. Save values only after the reviewer confirms the analyzer's structured result. Why this works. An end-to-end lightweight extraction client must upload content to the analyzer, invoke it to obtain structured results, present those results for human review, and persist only approved fields. The Choose 3 format captures the core upload or invoke and review or save steps required by the official bullet. You completed all 45 questions. Turn every miss into a focused study task. Explain the concept in your own words, identify why the distractors fail, and revisit the related objective in the current Microsoft Learn study guide. Thanks for learning with WebLizard CertLab. Continue with the AI-901 course playlist, review the latest Microsoft Learn study guide, and subscribe for the next practice session. Keep building your confidence, one concept at a time.